Okay, and then for this last theorem, I like to call this one secant tangent because you'll notice that T is a tangent line. It's just touching the circle. It doesn't go all the way through the circle, right? And then you still have your secant ZY here, and they go to an exterior point P. So this is similar to the last one we just did. If you'll look, this was both lines went all the way through the circle. This one strategy we're doing now, one just touches the circle. So the one that goes all the way through the circle, you'll notice the formula hasn't changed at all. It's still the outside piece of that segment, of that secant, times the whole secant, y plus z. And then the other side, you don't have an outside piece and an inside piece. It's all outside. And so we're just going to take that tangent and say we need two of those. Let's square that. Tangent times tangent. Instead of outside piece times inside piece, it's just two of those outsides multiplied together. All right, so a lot going on in example 5. Here we go. Says find the value of each variable using the given chord, secant, and tangent lengths. If the answer is not a whole number, round to the nearest tenth. Okay, so I'm noticing a lot going on in part A. I've got yellow line, which is a secant, goes all the way through the circle. Green line is a secant, goes all the way through the circle. And blue line, which is a tangent because it just touches the circle. Other things I'm noticing that the 15 and the 7 are both there. They have numbers for both pieces of the green line, whereas the blue and the yellow both have variables. So let's do this. We're going to use two different strategies. Let's maybe start with, let's just do two lines at a time. It would make sense if we use the 15 and 7. Because those both have numbers. So let's maybe start with the secant tangent strategy, in which case I'm going to use, the green secant and the blue tangent. Okay, so let's go up and look at what that strategy was exactly. The secant tangent strategy says for the secant part, the green part, I'm going to take the part outside the circle times the whole thing. 7 plus 15 is the whole thing, is equivalent to the tangent one, the blue one, squared. So we know that gives us 7 times, in parentheses first, order of operations, this would be 22. And then we know 7 times 22 is going to give us 154. And then the last thing we have to do is get rid of that 2 on the y, the squared. So the opposite of squaring is to square root. What you do to one side, you've got to do to the other. And so square root of 154 is, to the nearest tenth, approximately 12.4. So y equals 12.4. Okay, then for the second part, because we've only solved for y, we still have to solve for x. I'm going to do, you don't have to, but I'm going to do the secant formula strategy, which was on the last page, right? Because I have two lines going all the way through the circle. So I was thinking if I used the green line and the yellow line as my two secants, that I could solve for x that way, because I have all my numbers on the green line and only one piece I don't know on the yellow one. So yellow secant would be the part outside times the whole thing, which is 5 times 5 plus x. And then the green would be the part outside times the whole thing, 7 plus 15. So if I distribute the 5, I'm now solving this equation. I get 25 plus 5x. I'm going to kind of cut that off there. And then this is 7 times 22, which again is 154. And then we're going to subtract 25 from both sides. and that gives us 129. And then to get x by itself, we're going to divide by 5, and x comes out to be 25.8. Whew! All right, that was all just part A. So now let's go look at part B. Okay, again, on this one I have 3 lines. It looks like I have a chord because it doesn't go outside the circle. I have a secant, and I also have a tangent. So lots of things that I'm thinking about. I'm noticing I have 2 variables, an x and a y. So I'm going to hold off on dealing with the green line, and I'm just going to do secant tangent to find x. And so tangent one being the one that's just touching the circle, the blue one, and then the secant being the whole yellow line, right? So the tangent part we square, that's the formula up here, is that you do the one that's touching the circle squared, t squared, is equal to, you do the part, so here's my circle, right? I'm going to do the part outside the circle times the whole secant, the whole yellow secant is 7 plus 5 plus x. Okay, so now we'll do 121 equals 7 times 12 plus x. We're going to distribute the 7. So 7 times 12 is going to give us 84. 7 times x is 7x. So we'll subtract 84 from both sides. And that comes out to be 37. And then lastly, to get x by itself, we'll divide both sides by 7. And to the nearest tenth, x comes out to be approximately 5.285. So I'm going to say 5.3. Okay. And then for solving for y, we've still only solved for x. So now I'm going to ignore everything outside the circle, and I think I'm just going to treat this as 2 chords inside the circle, right? If you ignore all of this, you have chord. So let's go back and look and see what chord was. That's where you said A times B equals C times D. Okay, so we have 5 times x, which was that 37 divided by 7 number. It was 5.2857 if you wanted to use all the decimal places, equals 9 times y. So remember what we do is we do the 2 pieces of the green chord equals the 2 pieces of the yellow chord. So this 37 over 7, that is our x because we already figured out what x was. It was 5.3. I just wrote it in fraction form. You could have written the 5.3 there. Just make sure you use all the decimals. So that number times 5 in my calculator comes out to 26.428 approximately. So now what I want to do, so I just multiplied those 2 together to get, to get this number. Now we're going to divide by 9 to get y by itself. And you get y to be 2.9. So now we have x and y, and that was all just part B. Whew! All right, so now pause the video and you try. So first of all, you noticed, I hope, that you had a tangent line. Sorry, tangent line was the blue one that touches the circle, and the secant line that goes all the way through the circle, right? So it doesn't matter any of this part beyond where it touches the circle. We only care about the distance from that exterior point to where it touches the circle on the tangent line. All right, so our tangent line, we take that and we square it. That's the formula, is equal to the part outside the circle, right, times the whole yellow secant. And then you've got your equation. So let's solve it. So this is going to be 49 when I distribute 7 times 7 plus 7 times x equals 100. Then we're going to subtract 49 because now I'm solving an equation. I'm trying to get x by itself. And so that gives us 51. Divide by 7. And x comes out to be 7.28. So to the nearest tenth, 7.3.